One of the common things we're going to have to do when working with the Raspberry Pi is to essentially debug systems remotely. So our Raspberry Pi that we see right here essentially is not the machine that we're going to actually compile our code on or work with our code, build it on, so on and so forth. We're actually compiling on a virtual machine, and we want to transfer it and do our debugging on this Raspberry Pi. That's going to involve some things being set up a little differently inside of our Eclipse environment. So in this tutorial here, what I'm going to do is walk you through first, how do we remotely run code on the Raspberry Pi? Then that's going to be followed up by how can we remotely debug code on the Raspberry Pi. So let's get started. I want to log into our virtual machine here, and I'm going to start up Eclipse like so. Now in this particular case, I have an Eclipse program that I have written and compiled, and it is all set to go. As soon as Eclipse starts here, I can compile up the code, but I can't run it. I can't run it because, of course, the code is targeting the Raspberry Pi. So since the code is targeting the Raspberry Pi, I have to deploy it out to the Raspberry Pi to work on it. So this is the path to my workspace. I'll launch it, and as soon as Eclipse gets started here, what we'll see is I have, in this particular case, a single project that is set to go for compilation. Okay, so at this point we can see that Eclipse has started up and we have a program here. Basically what this program does is one thread happens to turn a light on when the button is pressed. The other one, called the down button thread, does the exact opposite, turns the light off. So my main program here, what it does is it sets up the GPIO pins, and then it will set the directions so that they are outputs and inputs as appropriate. And from there, basically sets up some scheduling related things and lets the process start running, joining, waiting for the threads now to terminate if we get to a point of needing to shut down. Okay, so what I can do is I can build this code, and it will go to town here, compiling away. It's going to do the make all, run the cross compiler as we would expect, and we can see now that it is actually built a binary, but I can't do anything to run it. I can't do anything to run it because I need to run it on my Raspberry Pi here. So what I want to do now is set up a runtime environment that is now remote to my Raspberry Pi so that I can run my code on the Pi. So to do that, go up here and I select the project, and I right-clicked. I'm going down to this run as, but instead of trying to run as a container or a local C++ application, both of which will not work for this, what I'm going to do is I'm going to select run configurations because I need to create a new run configuration for my system. And I'm going to select this one here, make this just a little bit wider so you can see it here, what is referred to as a remote application. What that will do is it will actually run the code remotely on the Raspberry Pi, not on my local machine that I've got. So I'm going to select this, and I'm going to go up here to create a new configuration for it. So this new configuration now is going to allow me to configure out my system so that it will run remotely on my Raspberry Pi. So if I go down here, my connection, what I want to do is I need to first off set up a connection to my Raspberry Pi. I'm going to set mine up to use SSH, which is a secure shelled connection. So I'm creating that, and what I'm going to do is I'm going to name this. Whoops. Shilling Pi 4, and the host is going to be Shilling Pi 4R dot local, like so. My user is going to be Pi, and I want to set up password-based authentication for this. So this is all said and done now. I click on Finish. This will take just a moment here to get ready and get back to a screen. Why is this taking so long to respond? Okay, the connection is Shilling Pi 4. And it's all set. Now what I need to do is I need to figure out, well, where do I want this code to run on the remote machine? So the remote absolute path, this is the path from the root of the Pi directory to where I want the code to run at. So what I'm going to do is I'm going to actually click on Browse. And what this is going to do is take and create a connection to my Raspberry Pi that I have here so I can see the file system. Username obviously is Pi. And I'm going to enter in Raspberry, which is the password that I have by default right now. So it's going to connect. I'm going to put in my password that I have here for my system. This right here is the file system /home/pi, and I can browse inside of this. In my case, what I'm going to do is I'm going to place this, in my case, into a directory called remote test. That's where I want my code to be placed at. That's where I want all the executions to occur. Okay, so I've got that set now. This will respond here eventually. I can apply that. And now what I'm going to do is I'm going to run this setup. So if I click on Run, what's happening is, if we look down at the bottom here in the console, the code is going to be remade. Nothing to do for it because it's pretty clean already. And it has SSH'd it out to the Raspberry Pi here, placed it, and tried to run it. Now, if we notice here, it ran with this output here because I didn't give it any parameters. If we look at how this code is structured here, there are command line parameters passed into it for the different GPIO pins and the inputs and outputs. So what I need to do is I need to set up those parameters so that those get passed along and actually can run with the program on the remote machine. So to do that, what I'm going to do is I'm going to open up my run configuration again. And I right-clicked here. It should be coming up momentarily. Okay, I'm going to go down here to Run As again. Look at my run configurations. And there should be the configuration I just created that should be available. I'm going to go over to this tab called Arguments. Arguments are basically command line arguments that are passed along to the program. So if I look at my Raspberry Pi here, what I'm going to do is I'm going to have my first output pin here be GPIO 6. I'm going to have my second output pin here be essentially GPIO 4. And I'm going to have my inputs be on pins 16 and 19. So these are the command line arguments that will get read in with main when the program runs. I now apply this. Click on Run. We'll see the code go through the same process again. Trying to rebuild the code. Obviously there's nothing to be done because I haven't changed any dependencies. The program is running, and what we can see is, if I lift it up here, when I press the button, the light turns on. When I release it, whoops, actually exact opposite. When I press it, release it, it turns on, press it, it turns off, so on and so forth. If I do the other button, behavior turns on when I press it, release, press, release. So exact opposite between those two. And I could change around the inputs or the outputs for these buttons by just changing these parameters around. When I am done with my session, what I end up doing is I will click on this little terminate button. What that will do is it will terminate the process on the remote system, and my system is now able to run normally. So this shows us how we can deploy and execute code remotely on the Raspberry Pi. So previously what we did is we set up the ability to remotely deploy and execute code on our Raspberry Pi using Eclipse. What we'd like to do now is be able to set up so we can debug on our Raspberry Pi code, again, using Eclipse and using the tools that we have the capability to communicate with. So in order to do this, we have to make sure a couple things are actually happening. So the first is we need to install a tool called GDB Server, or make sure it's installed on our Raspberry Pi. So what I'm going to do is I'm going to open up a shell connection to my Pi. So here we are. I'm logged into it. And what I want to do is make sure that we have the GDB server installed. So I'm going to do sudo apt-get install GDB server. This is some code that will run on the Raspberry Pi that will allow us to communicate with the GNU debugger over a remote connection. So we see it's going through, it's fetching, setting some things up. Now I have GDB server installed on my machine. So I can exit out of this connection because I'm not going to need it anymore. So now that we have set up our Raspberry Pi device here so that it has the remote debugger system software installed, we need to go in and set up our host environment that we're doing a cross compilation on so that it is ready to go with cross debugging. To do that, we have a simple installation that may or may not be necessary, GDB multi-arc. By definition, GDB is for the host environment, the OS that is installed on the machine, which in our case here, since we're developing on a Debian kernel, basically what we need to do is we need to install multi-arc so that this architecture that we have here also supports the ARM that is coming from the Raspberry Pi. This is done once basically on the host virtual machine in our environment, and now we can actually remotely debug with Eclipse or with other tools. So to set that up, what we want to do is go into our Eclipse settings that we were in before here, and whereas before we went down to the run setting here and did a run as, we're going to go down to the item that is below, debug as. So let's go into our debug configurations here. So our debug configurations, we've got by default now a multi-threaded debug setup for remote debugging based upon the settings that we put up for our project. We need to make sure that our build configuration here is set for debug so that it actually does work with the debugging settings that we've added in. And we're going to need to check and make sure that the connection is correct, which in our case, most likely it's going to be. In our case, we're going to shilling Pi 4, which is the Pi that we were at before. And this is the remote path we had in. One more thing we need to check. We need to look at our debugger here. So our debugger, what we need to make sure is that instead of using just GDB, we are using GDB multi-arc, like so. The GDB that we just installed right here. So I'll make sure I type that in right. multiarch. All right, so that is all set to go. Now what I can do is I can click on Apply and go back over to our main tab here. Close this out. And go into my debug configurations. And I should be able to, program does not exist. I should be able to now go in here and do a build all. So we'll go through compiling all the code. So the code will compile, should compile cleanly. It has before in our other debugging sessions here. And now that that is all said and done, I should be able to go in here onto our debug configuration, select the debug configurations tabs, and we are now ready to go. I click on debug. Down here we're going to see it going through, seeing if it needs to make all. It's going to make all, didn't really need to do anything. We logged on. Give this just a few moments to finish communicating. You see the remote debugging has started up. We're communicating. That is the IP address of my remote machine. And we will see that my code is running. I am stopped right here in main of the code that is running on my Raspberry Pi here. So I can use now all of the standard commands that I can do in Eclipse. I'm going to step over these parameters, and we can see our various values getting set up here for arg, or for GPIO out 0, 1. These pins are getting set over here based upon the parameters that were passed in as arguments. We're going to see our objects getting instantiated here, like so. So they've been instantiated. We set our directions up like so. Our pins are being set to active low. Now you'll notice right now there's just a single thread over here. What's going to happen is now I'm going to start another thread running. So we started up another thread. We can see that a second thread is running. And if I double click on this here, we can see where it is in the code, all the various frames, and we can look at where this code is at. It is in basically waiting for an edge at this point here. So we can do that. If I go back over to main, like so, I can step over this other thread, and we'll see this other thread getting started now. So I've got thread 1, which is my main, thread 2, which is, in my case here, the method called down button thread. Very creative name, I must say. And then the other one is, of course, up button thread. I've got this all being debugged. I can click on resume. And if I look at my board here, my lights respond to button presses appropriately, turning lights on and off as they should. If I wanted to go into some of the various pieces of code, I could set a breakpoint up here. So if I wanted to put a breakpoint, for example, when we came around to this line right here, I can double click right there, set a breakpoint, resume. So the code is running. Now, depending on which button it is, if I press, we see that we went there, and as I press the button, we got to that breakpoint. I can now start debugging by stepping over the code. So we'll see what will happen as the code is running and as it continues to execute. So now I can do all of the debugging that I would like to do remotely on my given system, and again, go back to allowing it to resume and execute as would be expected. When all is said and done with this debugging session, I can go over here, terminate it, and now I'm done with my specific debug session. So at this point, you've seen how to remotely execute a program using Eclipse, and you've seen how to remotely start the debugger using the multi-architectured debugger, and you should be in pretty good shape to be able to at least cursory start debugging code on a remote target using the Eclipse environment. That's going to bring this video to a conclusion.